So he's not just a CEO and co-founder, but he was actually, in the trenches developing the tool. And so obviously he's a programmer. He's a self-proclaimed tech geek, and obviously a business leader for success with Altova. I believe he started Altova in Austria, but has moved to the U.S. in around 2001, and is a member of the Marblehead Rotary Club in Massachusetts. And he's an active angel investor, so if you have any great ideas, reach out and contact him. With that, this webinar is going to be about how to work with XBRL data directly from the SEC. It's a really interesting approach in XBRL US. Process SEC filings, and we shred them to a relational database to work with that data. So I'm very interested in this, as we'll be looking at an alternative way of working with the XBRL data and working at it in its native XBRL form directly with the SEC. So with all that being said, please welcome Alexander Falk.
Thank you, Philip. Appreciate the introduction. As we get started here, I wanted to give you a quick outline of my presentation. We're going to essentially cover it in 2 or 3 parts here. The first part is about how to download all of the XBRL data from EDGAR and get it onto your local machine. So we'll discuss how to access the SEC's EDGAR archive and look at all the XBRL filings there via the RSS feeds. We'll talk about downloading the zip file enclosures that contain all of those filings, and we'll discuss briefly some special considerations for the early years. If you're interested in the filings from the 2005 to 2007 area, there's some extra work you got to do. Then we'll talk briefly about how to organize those filings on your hard drive. As Philip mentioned, in this approach here today, we're not going to shred the data and put it into a database. Instead, we're going to just keep the files as XBRL files on our hard drive and then process them anyway. So we need to think a little bit about how to store and organize those files. We're talking about a total of, as of last week, 105,800 zip file, totaling about 14.1 gigabytes. So we need to put a little bit of thinking into that. And then we want to make them accessible, obviously, by date range, by CIK number, central identity key number, or by ticker. And last but not least, we want to process those links, especially doing some XBRL validations on them to look at data quality and then other issues. And then last but not least, we really want to try to extract some useful information from these filings, for example, some financial ratios. So that's the outline for today. If at any point in time, as Philip mentioned, there are questions, just use the moderated chat window to post them, and then Philip will read them out, and hopefully we can cover them at some of those natural breaking points in the flow of the presentation.
Which I think is right now, because I do have a question that came through.
Very good.
So the question is, the slides and replay of this webinar is going to be available. I just want to address that. We do record the webinars, and it will be available, and we'll also, I believe, Alexander, correct, we can make the slides available as well. Is that right?
Yep, I plan to post those on SlideShare, so they will be available, and also the Python scripts and other code that I'm discussing today. We'll probably publish them on GitHub in a couple of weeks, so you can get all of that information and then use it for your own means. Okay. So talking about the data that's available on the SEC's EDGAR system, it's really a wealth of XBRL formatted financial information that we have there, 9,700 corporate entities. And while it can seem at first like a daunting task to manage and start working with that data, or creating a database where you can really pull the first data point, what I want to show you here is how you can just download the data from the SEC, put it in your own computer, and then perform any processing and financial analysis locally on that data, even without building a large database first. And I hope that this will sort of spark some new ideas, processing, and just increase the adoption rate of this treasure trove of financial data that's available essentially for free out there if you just do a little bit of programming. Talking of programming, for all the source code examples, I'm going to be using Python 3. Simply because it's a very nicely human-readable language, so it's good for walking through the code and understanding it, even if your background is in any other programming language. And it's also widely available on all operating systems, so you can use these examples and the Python here on Linux, on a Mac, on Windows, whatever platform you want. So before we get started with the details, I want to talk a little bit more about the sort of fundamental question, why don't we just store it in a database? There's nothing really wrong with the approach of storing it in a database. As it was mentioned, XBRL US has a very powerful database where they do exactly that, and it has a lot of advantages. But I also find 3 points that I want to mention here that sort of point out a favorable treatment for the way we're going to do it today. One of them is any kind of rules. That's just much easier to do if the calculation link-based inconsistencies and other things can directly be produced by an XBRL validating processor. So the benefit here is to keep the data in XBRL International has new standards like XBRL formula and the XBRL table link base that are going to provide great potential for future applications that, again, requires the data to be in the original XBRL format in order to apply these standards to the data. And last but not least, being sort of coming from the XML side of things and XML schema and XQuery gives us the advantage that we can, of course, now apply XQuery processing to the XBRL data, and that only works if it stays in its original XML-based format. So without further ado, let's talk about where we get the data from. So the SEC obviously has a couple of very nice web pages where you can browse the financial reports direct there, where you can retrieve the XBRL filings through a human web interface. But at the same point in time, you can also get RSS feeds from the SEC that have all the XBRL filings that have ever been received and processed by the SEC. And that's what we're going to use to start working with that. You have some links on your screen that point to those web pages that have all these RSS feeds. And in particular, there's a historical archive of all the filings with all the XBRL exhibits that have been submitted to the SEC since the inception of the voluntary program in 2005. And this monthly arc that we will start working with, that's our starting point. And there's one RSS file per month from April 2005 until the current month of March 2014. So how does RSS look like? If you've never looked at an RSS feed with an XML editor, this is what it looks like. Essentially, it's an XML-based format that has originally been created for news items and other blog posts and whatnot. Here it's used to wrap all the XBRL filings. And what we see essentially is, and I'll just highlight that real quick with this pen here, is one item element for each filing in that particular month. And we really are interested in two pieces of data from that item element. The first one is the actual enclosure file, which is what the zip file URL is where we can download the actual filing. And the second one is the CIK number here, which is the unique central index key for that creation that identifies that particular filer. So we're going to extract those two pieces of data out of the RSS feed and then use that to download the actual filing. If you've done that already before, bear with me. I think many people here in the seminar haven't done it before, so I just want to walk you through the process so you can see that it's actually fairly easy. So to download that RSS file feed, all we need is the actual URL where we can find it. And it is nicely structured by year and by months. So we just calculate those for the particular months that we want to download. We make sure that we have some local directories ready to receive those files. And then we use the Python URL lib package, and in particular the URL open function, to just open that RSS feed and read the entire feed into memory. And once we've done that, we can actually start parsing that RSS feed. In this particular case, we're going to use a very lightweight RSS feed parser package in Python called feed parser, and it allows us to access the individual elements from that particular RSS feed. So we walk through the list of all the enclosures in that feed. Obviously, on my outer loop, I'm going to walk through all the items in that feed because I want to retrieve that data for every single filing in the archive. And then once we have identified the zip file enclosure, we can get its particular href attribute, which contains the URL that we can actually download the filing from. And we also want to retrieve its CIK number. And then when we have all of that, we will download the file and copy it into a local directory on our machine. So to do that, all we got to do is, again, open that particular URL that we just found under enclosures, read the entire file into memory, and then write it out to our local hard drive. All very simple things in Python. We add a little bit of error handling in between so that it fails gracefully if something goes wrong. But other than that, this is a fairly simple approach to download all of the data. Now, I mentioned earlier that we have to take a little bit of special considerations into account when we talk about the earlier filings. The reason for that is that in the first couple of years, the XBRL filings to the SEC did not always contain a zip file enclosure. So even for some of the filings in 2008 and 2009, definitely for all of the filings from 2005 to 2007, we actually have to, if we're interested in that data for analysis today, we have to do a little bit of extra work and download each individual XBRL file individually and then zip them up locally on our hard drive so that then in future steps, we can process them all in the exact same manner. And I'm not going to walk through that code in great detail, but you can see that when you download the slides later on. Essentially, what we're doing in that particular case is we need to extract every single element from the filing and then walk through all those individual files. So in this particular case, that's both the instance document as well as, of course, the taxonomy, the collation link base, presentation link base, and all the other components that make the entire filing. And then we're going to simply use an XML parser in Python as well as a zip file packaging utility in Python to just write those files to my local hard drive and then simply create a zip file where we have all these files zipped up nicely. So let's look at that in a quick demo here. I'm going to go to my shell window here. I'm doing this on a Mac, but it would be the same process on any other platform where you have Python running. So I can go to a little that I've prepared here called load SES filings. And you've seen some code snippet in the past couple of slides. If I call that just with the command line parameter -h, it gives me a little help information, so I can pass in a particular year or month, or I can give it a whole range from a year to a year. Since I've already got most of the data on my local hard drive, I'm going to just call it up with, where are we? With, in particular, the year 2014 and month 3 for the month of March. And if we do that, it's going to download the actual RSS feed first, and then it will walk through that and process every single filing. And you can see that it's downloading various filings now, one after the other. In this particular case, it's the ones that were posted yesterday and today, because I deliberately did not download anything in the last 2 days, so I can show you today for this demo how fast you can actually get that data from the SEC. And then once we get to about 2 or 3 days ago in terms of the data, you will see it scroll through much faster, because what we are doing is we want to be nice citizens of the internet and not overtax the SEC servers. So whenever I determine that I already have a local copy of the particular filing in question, I simply skip the download and don't download the file again. There we go. So in any of these cases, it now simply says local copy already exists. And so it took me, what, about all last 2 days to my local hard drive. To point out that when you intend to download all of the filings from 2005 until 2014, 9 years filings, 105,000 documents, 14 gigabytes, please don't do it in the middle of the work week. The SEC would be very happy if you do that either overnight or on the weekends or in smaller portions, because you don't want to just grab all the bandwidth yourselves here. So now that we've done all of these steps so far, what do we have on a hard drive? We essentially have
Alexander, I just want to
yes.
interrupt a moment. Just a couple of things. There is a question about whether we're going to have the webcast offline. I just want to reiterate, it's being recorded and we will have that available probably the next day for if anyone's having trouble watching the webcast at the moment. But the other thing is when you were showing the RSS feed and walking through the kind of some of the components in the RSS feed, there was a question about can the form type and the filing date be used as a reference point for the indexing? And I'm wondering if what we mean by that is can you access these files looking at the filing date and the form type for it? So with a lot of times people know I'm looking for like a certain company with that was filed on a certain day, for like the Q or the 10K.
So in terms of the data that I'm using at the moment on my hard drive, I have to actually open the filings and extract that information. And we will see that a little bit later in the presentation. But nothing would prevent you from utilizing that same information and either storing it in some metadata separately or storing it in encoded into the file name. But you can definitely amend the process and do that. In my particular case, what I'm doing is I'm only looking at when I later on calculate my financial ratios in the latter part of the seminar. I'm only looking at 10K and 10 filings for that purpose. But I do that after I already find all the files. Okay. There's nothing that would prevent you from doing it earlier on.
So if you wanted to be able to have a way of accessing the files by filing date and document type, as you're saving the files, it's something you could add to the file name or
exactly
set up some structure for capturing.
Exactly. It. You can capture it in the file name, or you can capture it in a separate file, in some kind of index file or directory tree file. But it brings me to a good point here. What I'm doing essentially is exactly that with the CIK numbers. So when I download all those filings, I actually only get this file name here for the enclosure from the SEC. And what I do is I insert at this particular point the CIK number of the filer so that I can later on retrieve the files more easily when I want to sort them and organize them by filer or by either by CIK number or by ticker. And nothing will prevent you from also storing the filing document type into the file name at that point in time. It's just a little tweaking of the Python script to do that.
Okay.
So we are here at this next step anyway, where we're talking about how these files are organized. Since we're trying to avoid using a database, we're just using the file system. So I have a subdirectory SEC here where everything starts. And inside that, I just have one directory per year. And within that directory per month. And then inside those directories, I have the actual filings with the zip file name from the enclosure in the RSS feed. And then with the CIK number inserted in the beginning to facilitate easier location of all the filings for one particular entity. Now that I have that, of course, we need to solve one last piece of the puzzle, and that is how do I get from a ticker to a CIK number? It's a question that's being asked on various forums all the time, so I figured I'd answer it as part of this webinar as well. There is a web service available from the SEC under this URL that lets you get all the company information, including all the filings, based on a search by either CIK number or ticker. and it lets you retrieve the output as XML. So all we have to do is we have to call this with the ticker symbol, for example, ORCL for Oracle, and it will return to us the last 10 or however many we want, as well as the CIK number. And then we can extract with a simple XML parser the actual CIK number from that information here. And so once we have done that, we get to the real meat of how we process that data. We now have all the records, all the XBRL filings on our hard drive, and so we want to do some work with them. And that brings me to this step here. Obviously, since our own XBRL processor, Raptor XML, is very much suited for this kind of work, we're going to use that for the purpose of this webinar. One of the benefits here is that Raptor XML can directly process the XBRL filings, even when they're stored inside a zip file. So there's no need to unzip them first. Raptor can simply update them directly inside the zip file. So we save ourselves any manual extract step there. And because Raptor XML is highly optimized for parallel computing architectures, it can process large amounts of XBRL filings all at the same time. So we can pass an entire batch job of filings to Raptor XML all at once. And from Python, we can simply do that either with a simple shell call, which is what I'm going to use here in this demo. Or if you want to build a more scalable system, you could also pass the information to Raptor XML over the HTTP API from one server to another. That's totally up to you. And so here's what we do to build that list of jobs that we're going to then pass on to Raptor XML. We'll see in a minute in another live demo how we actually built a little Python utility around this. And in that Python utility, we pass in as a command line parameter a list of tickers, as well as a list of tickers or CIK numbers, depending on how we want to search for it, as well as a range of years and months. And then we essentially locate the files that match that criteria with a little Python function that we call append job list. And so what we do here is we now go through that file system structure that I showed you before, essentially walking through the target directory. We find the SEC subdirectory as with its subdirectory for the year, with the subdirectory for the month, and then simply walk through that list of directories here in our Python code. And all we do is we now check whether or not the file starts with one of the CIK numbers that we're searching for. Very simple approach, nothing fancy. And since the question came up, could you also at that point in time search for filings just by document number? As long as you encode that into the file name, that's very easy to do. And we could do that here with a file name .contains or similar match in Python. So let's take a look at that. We're going to go over to our desktop again, and this time around we're going to start our validation script. And what this does here is, probably do it in a window that's not that confusing. Give me 1 second. So in this validation script, we have a couple of command line options available. One of them, obviously, is to pass in the year or the month. We can pass an entire range of years, and then we can search for filings either by CIK number or by ticker. The script we'll use a little bit later. So if I want to, for example, search for filings by Oracle from 2010 through 2014, I can do that with this command line. And once I trigger that, the ticker Oracle is going to be transformed into a CIK number, which is 1341439. And then we're going to search for 16 files that we found, passing them all as a batch to Raptor XML server. And it's running the batch validation on all those jobs. And in 5 seconds, will tell me that all of those filings are valid and returned a result of OK. So that's good. Let's look at another company. Maybe we use, I don't know, Apple instead of Oracle. Filings for, again, the last couple of years. For Apple, we get a different CIK number, and of course, in this case, we again batch run through all these validation jobs, and lo and behold, those are not all okay. If I scroll back here to the beginning of these error messages, or warnings, I should say more properly, you will notice that the first couple of filings we found all gave us a result of OK. And so this is what you can see here. The first couple of filings all look good. And then we found inconsistencies with respect to the calculation link base. So for example, in this particular case, if you look at this error message line here, there is a calculation arc for a summation item that is inconsistent with the actual data that's being added together. And we see a couple of those error messages popping up throughout all of these other filings. So this is the way how we can now access all of these filings and validate them as we see fit.
When
Please.
you're doing that process, you're putting in the ticker. So it's then going back to the SEC to kind of find out what the CIK is related to that ticker?
That is correct, yes.
And then getting the list of filings from the SEC.
No, it's not.
And then you take
nope, it's at that point in time just searching my local hard drive for the filings based on this key number.
That's what I was trying to figure out. So you're just using the SEC to do the translation from ticker to CIK.
It's a simple convenience question that we can use ticker symbols instead of CIKs. Only for that I'm calling out SEC at that point in time. Otherwise, and that step could be done with a local translation table to save network resources.
And then the next part was you were going through the files on the local file system that have already been pulled from the SEC. And
that is correct.
And then you're processing.
That is correct, yes.
Okay, great.
So now, of course, the next question here is when I process those filings, it's nice to know that some of them are valid and some of them have some inconsistencies, but these data quality issues are not really news. The XBRL website with the data quality checker has some very nice data on the statistics on how many filings have how many problems. So it's certainly again a validation for the question of whether or not the SEC shouldn't put on more stringent checks on the data it accepts, but it doesn't really give us any new insight so far. So the question I wanted to answer next is, can we get some useful financial ratios out of these XBRL filings now that we have them on our local disk and now that we can process them very efficient, very quickly. So for this particular demonstration, I want to look at three simple ratios in the balance sheet. I want to look at the current ratio, which is commonly defined as current assets divided by current liabilities. I want to look at quick ratio, which is sort of a measure of how liquid, what the liquidity status of an organization is. In other words, how quickly could they satisfy their liabilities with cash or anything that can be converted to cash fairly quickly. It's defined in 3 or 4 different ways in the literature. The formula that I'm going to use here is essentially cash plus short-term markets plus accounts receivable, and the whole thing divided by current liabilities. And then just as a fun extra exercise, there's also a cash ratio, which essentially leaves out the accounts receivable out of the above picture, because sometimes those may be only collected within 90 or 100 days. And if you really want to see what's immediately available in cash to satisfy those liabilities, the cash ratio says a lot more than the quick ratio. So how do we go about extracting those from our filings? Well, in this particular case, we're going to use an additional feature of Raptor XML and simply pass in some Python script code and ask Raptor XML to execute that whenever the filing has completed the validation. So The model that we use here is from our Alta Python code you saw before. That's basically walking through all these SEC filings. We now pass an additional script parameter to Raptor XML, and when the validation succeeds, the Raptor XML server is going to call our function on XBRL valid in a separate Python script. The reason the second script is Python is because Raptor XML actually contains its own built-in Python interpreter, which makes the entire XBRL instance document and the DTS and the schema available to programmers to build extensions onto the validation process. And so that's exactly what we're going to do here. We are going to look at the current ratio as those interesting parameters. And in our script, in our Python script that's now going to be called after the validation is completed, we get the entire instance document, we get the entire DTS, so discoverable taxonomy set, we get all the link bases available to us wrapped nicely in Python APIs. And to make it even more understandable for this webinar, I've created a few helper functions that just help me locate the relevant facts from within the filing, because I really want to talk a little bit more about the high-level aspect of that involves a little bit of thinking about whether or not those facts have dimensions or not and what their contexts are. So it can get a little tricky in the details there, which is why we want to publish the code for this later on GitHub, so you can actually take a look at that. But for this discussion, if I want to calculate the current ratio, it's defined as current assets divided by current liabilities. So I have to look for two facts in my XBRL filing. The first one being assets current, and the second one being liabilities current. And once I have found those two facts, all I have to do is calculate my current ratio by dividing one by the other. Fairly simple and straightforward. However, not all of the ratios that are used commonly in financial analysis can be easily calculated from elements that are actually found in the US GAAP taxonomy. There is a really nice draft research paper available by Roger Debreceni and others entitled Feeding the Information Value Chain, Deriving Analytical Ratios from XBRL Filing to the SEC. The draft paper is dated December 2010 and is available on the web under this URL here. And it goes into great detail on looking at what financial ratios are easily calculated from XBRL filings and what ratios are a little bit more difficult to calculate. And the reason some of them are more difficult to calculate is you have to actually consider the fact that the filer has a certain amount of freedom and liberty on exactly what elements to use in their filings. Not even talking about extension taxonomies here, just based on the regular US GAAP taxonomy, there is a certain amount of liberty on what elements are going to be included in a particular filing. So one has to take great care to find the correct element and sometimes walk through the calculation link-based chain and identify where it matches for a certain concept. And I want to illustrate that here with the next calculation. At this stage, what we're trying to do is not just calculate the current ratio, which happens to be very easy to calculate. We want to calculate the quick ratio. And for the quick ratio, we need a couple of extra elements here. So the formula is cash plus short-term marketable securities plus accounts receivable divided by current liabilities. So first intuitive step, of course, is we're going to look for a fact called cash. But what if that's not in the filing? Well, in that case, we're going to go to plan B and look at cash and cash equivalents at carrying value. And if we can't find that, then there's still another item that we can identify as option C, which is cash, cash equivalents, and short-term investments. And by walking this calculation chain and determining which of those items is available to us, we have the ability to actually calculate that ratio. Now, keep in mind that what Roger found in his draft research paper is that with doing these simple steps, you can increase the percentage of XBRL filings where you can actually calculate that kind of ratio from somewhere like around 60% to 97%. So it's definitely worthwhile taking these extra steps. Similarly, for marketable securities, we need to look at both marketable securities current as well as, if that's not found, available sale securities current. And even a third step should be added here, which I've done in a later version of the script that's not in this particular slide. We also need to look at short-term investments as another potential where we can find that value in order to calculate the quick ratio. And once we found all these data points, the rest is easy. We use the form that we defined above to calculate our quick ratio and print it out. So,
Alexander, I just want to hear this process where you're sort of looking at cash and then you're kind of falling back to other concepts like cash equivalents or carrying value.
Yep.
There's a question about that. Is this walking the chain? Is this done by Raptor XML, or is this something that obviously you've coded it here? This is something that the user has to code in the way they intersect Raptor XML?
In this particular example, I'm just looking at the raw data and the raw facts, and so I'm doing it by hand. It is definitely possible to ask Raptor XML to look at the calculation link base and calculate the values for me. However, keep in mind that we then run into the inconsistency issue that sometimes when we look at filings, the data that's produced by a calculation arc in the calculation link base is not exactly the same as the data found in the filings. So it then becomes a question of what do we trust? Do we trust the actual summation item if we find it, or do we trust the individual elements of that calculation arc if we found inconsistencies? So there are some questions in there, but it's not an automatic process.
Mm-hmm. And I have a question. The
Yes.
fact finder function that you have, is it in that function where it's interfacing with Raptor XML?
Yes, that's correct. That's correct. In that function, I'm actually looking at the instance document. I'm looking at the FASB namespace, the US GAAP namespace essentially, and I'm identifying the individual items from my instance document. The reason I've encapsulated into a separate function is because you really have to think a little bit about the contexts and the especially whether or not you have dimensions and pick the right items. And that's why it's much nicer to sort of encapsulate that for the purpose of this presentation.
Okay. And so what Raptor XML is doing, I'm just sort of trying to figure out myself, is it's really providing you that interface into the instance document in
That is correct.
Sort of a XBRL kind of point of view of that data.
It's a full-blown XBRL parser that gives you the entire high-level view of all the facts in the instance document, as well as the DTS and the calculation link base, and then you can use that to process it as you see fit.
There's a question about Raptor XML is this open source code, or what kind of licensing terms are there for Raptor source if it's not Raptor XML if it's not?
Raptor XML is not open source. It's a commercial product. And it's sold as an annual licensing model, and we have the data available on the website. There will be a link on the last slide for that. Okay.
And there was also, speaking of the ratio specifically, there was a question about the quick ratio.
Yep.
Which you have written cash, short-term marketable securities, and account receivables over current liabilities. The question is, could it have been written as current assets minus inventory over current?
Yes, that is one other way to calculate it. And they both obviously lead to slightly different results, and it depends on which literature you believe, but you can implement it either which way you want. We could do the same thing, we just would need to look for the different facts, right? We would look for the net inventory fact rather than the cash and cash equivalents fact and the marketable securities fact.
And lastly, I just want to point out, it's not exactly a question, but it is pointed out that in some of the previous webinars, I've talked about the normalization of data, which deals a little bit with what you're doing here in terms of, you're looking at cache, but you can't find cache, so we're going to fall back and let's try and find the cache value in another field like cache and cache equivalents at counting values. And I just want to point out that that is something that we've been working on at XBRL US and trying to build maps for doing this. In this case, what you've encoded here is a kind of map for doing that process. And I think I've said in these other webinars that there's what we're doing at XBRL US is one method, and clearly you're sort of encoding other methods of doing this kind of mapping and figuring it out. I just wanted to point out, I think it's kind of interesting that we do this kind of mapping by looking at a lot of things and trying to figure out when companies report cache and we don't, and then where they report that value and tags are they using.
Yep.
You mentioned Rogers, where I believe, I'm not as familiar with it, but I believe his work really looking at the way the author has built the calculation link bases and possibly other ways that the taxonomy is structured.
That's right. Yeah, it's based on walking the calculation link base and looking at the hierarchy of elements in the filing, trying to determine what is the best possible match for a particular high-level concept that he's looking for.
Yeah.
So and obviously, what I'm trying to show here is just what sort of the basic approach process is. Clearly, if you want to build this in a more scalable way for a production-ready environment, you use obviously something like a mapping approach where you predefine exactly what elements you would want to look for and how they relate to the high-level accounting concepts.
Okay. Related to that question, it was asked if we're going to be releasing those maps about how we've determined some of that. I just want to point out that is something we're trying to release. Right now, our maps are buried in a lot of our code, so we're trying to work extracting that. But we do have our intention of doing those mappings, how we approach it. Obviously, there are lots of other approaches. There's also a question about how this matching is done. Like you look for cache and then you look for cache and cache equivalents at carrying value and then cache equivalents at short-term investments, and whether it's done by map labels. But I believe here you're really looking at the true tag names and not the labels. Is that correct?
That is correct, yes. This is based on the actual tag names and not on the labels. Now, the interesting thing, of course, is that once you get the XBRL table link base standard to the level, could apply that here, it could provide an additional insight to how you can interpret and structure the data and extract it more easily. So that's an interesting area for future research, without any doubt.
And then I have a question that you don't need to answer right away, and when we get to actually you showing how some of this works, I think it's keep in mind. But it's a question on how fast this process be, like processing all these files for Python and Raptor XML, and what kind of timing you can expect to get results if you were processing a fairly large set of data. And the person who asked is pointing out that using tools like SAP HANA, they can get reports that are doing these kind of calculations fairly quickly, whereas they start using something like Oracle, it can take days to be able to process. And so they're just asking about your kind of experience on the timing of processing these files.
It really depends on how much data you want to extract and how fast you want to do it. In this particular case, we're obviously looking at particular filings for particular organizations, and I'm going to run a quick demo in a few minutes. We can actually see the timing there. But what you saw before, when we went through our filings for let me just switch over. Our filings for Oracle or Apple, and just ran a quick process of validating those filings. You saw that we got some real-time data of 5 seconds or so. That's the whole real-time from starting the out of Python code to the end of it. Obviously, if we look just at the validation code itself, then that's definitely less than a second for all these 20 or 30 filings. So we've really tried to optimize the process as much as we can. And in fact, when we look at XBRL validations for large amounts of data, for example, in our project in Indonesia with Bank Indonesia, we've been able to really crunch down on large amounts of XBRL filings being submitted to the regulator there by all the local banks and processing gigabytes of XBRL data in mere seconds. Let's move on here to the next step real quick. So the next step is to do actually another quick demo. Let me just clear the results here out of my shell window. And then what we're going to do now is run a little process, not just with one company or not, but rather what I'll do here is now look at all the filings from 2010 to 2014 for a couple of ticker symbols. Those happen to be some stocks in my portfolio. So I'm interested in what the current ratio and quick ratio and cash ratio for these companies are in the last 4.5 years or so. And it's the same call to my outer Python function that I used before, except that now I'm passing an additional script parameter here at the end that will be passed on. And for this particular demo, we're going to let that run now. Real quick, first of all, it translates all my tickers to CIK values, and then it's queuing up 244 batch jobs and starting to run through the screen here like real crazy. We'll let it do that. I am batching those jobs in portion of 20 and passing them to the engine in chunks of 20 jobs, just because I don't want to overtax my local little Mac here. If I want to do that on a server, obviously you can give it larger batches of jobs to do all of that processing. And so what I want to do here is look at some of that information that we've now calculated from those filings and extracted. So for example, here's a 10Q from Coca-Cola Corporation. And from that form, we've extracted now our ratios that we want to calculate. So we're going to look at the current ratio, the quick ratio, and the cash ratio extracted. Assets current and our liabilities current, and that allows you to calculate quickly what the current ratio is. Likewise, for the quick ratio, we've calculated what is the cash at hand in this particular case. It found it in the element cash and cash equivalent carrying value. We're looking at other short-term investments, which is the element that's used here to describe the short-term marketable securities. We're going to look at accounts receivable, and again, our liabilities current. And if we make that division now, we get to 0.91. And cash ratio, as I mentioned, is almost the same as quick ratio, except that we leave out the accounts receivable. So our cash ratio is obviously a little bit lower than our quick ratio. So that's one particular filing. If we scroll down a bit further, I just need to switch out of the drawing tools here. We can look at other companies. We can look at Google. We can scroll down all the way to the end, and we'll see that we got some inconsistencies and error messages from some of the filings. But to make life easier, if you really want to do some analysis now with that data, I actually have written all of those filings, all of those ratios that we calculated into a separate CSV file. And we can look at that next. Just as a quick data point here, if I don't have all the webinar software running to process all these corporate filings for 9 years and extract the ratios, including printing it on the screen, takes about 60 seconds normally. Right now with the webinar software running on my little tiny Mac here, it took 90 seconds instead of 60 seconds. And obviously, if you leave out all the printing code, the whole thing takes less than 20 seconds to process that amount of filings easily. Now, the output that I've used here from that extract ratios Python script is a simple CSV file to give us some of that data. So now for every single filing that we found, we see what the filing type is. I only looked at the 10K and 10Q forms in this particular example. We see the company name, we see the CIK number, we see the filing date, and then we see the three ratios that we calculated, our current ratio, and cash ratio. And what you'll notice is that these are all helter-skelter in a mixed bag, except for the dates. And that's simply because we batch these up in jobs of 20 or so filings and then send them all to Raptor XML at once. And they get done in the parallel processing world, and they get done, and then the output is written to the file. So we obviously want to look at that data in a little bit further away, then sort the output at the very end. And then if we do that and play a little bit more in Excel, we get to a picture like this. So that's the current ratio graph for essentially the time frame from 2009 to 2013 for some of these companies in my portfolio. And we can see that there's a wide range.
This is very appropriate because we were just getting questions about it. So if there's, how you can deal with graphical representations of the data.
Yeah, and there are multiple ways to do this. You can either, as I've shown here, as a very simple approach for the webinar, you can write out the ratios that you've calculated into a CSV file and then graph it from there in Excel. Or obviously you could create an XML output file from our extract ratio script and then process that with an XSLT style sheet to generate the graphs in either an SVG format or in any other format that way. You could use Altova Style Vision tool to do charts based on the XML data. There are multiple ways to create the graphical data out of it.
Okay.
And
we also are getting a question about, you're calculating some ratios that are pretty commonly calculated, so they're available in a lot of other places, like Google Finance and Yahoo Finance and things like that. So the question is, what are some of the advantages you get from extracting this XBRL data as opposed to reaching out to these other kinds of services for some of these common data and these common ratios?
Well, if it's a common ratio that I picked here, then that's only because I wanted to make it easy for demonstration purposes. You can basically look at any ratios that you want to calculate, and especially you would probably use this approach if you're an investor to calculate ratios that you cannot find in other places other than by buying a Bloomberg terminal and paying a lot of money for it. The benefit here is that the data is freely available from the ACC, and all it takes is a couple of tools to process it and extract the information from there. And by looking at the raw data in the form of the XBRL filing itself, rather than looking at what Google Financials, Yahoo Financials does with the data, you have a little bit more insight into how companies are reporting it. And then there are other ideas. I've been brainstorming with some other members in the community about what else you could extract. You could look at, for example, when did the company change the filer software that they used? When is some other break in their reporting that might be interesting to look at, and look at in general, for example, all the negative numbers reported in the filing. There are plenty of ideas of what we can do here. I just picked the current ratio and the quick ratio because those are very easy to understand and people are familiar with it, and this is a great demonstration case.
And I'd like to point out that the XBRL data itself provides a greater depth of data available. There's a lot more detail in it than Indeed. Is generally available certainly through the free data aggregator sources like Yahoo Finance and those kind of sources, but even more than for the paid data aggregators as well.
Yep, I completely agree. So this brings us to the last slide. Any more questions? I think we're also pretty good on the time.
There was a question when we were talking about that process of looking at cash and then falling back to other cash values, like cash and equivalents carrying value. There was just a question about if a filing has both cash and cash equivalents at carrying value, what would happen in that case, and would the cash be double counted?
In my particular script, I make sure they only counted once, so I prioritize them in a very simple manner. I look at first because it's the most closely related match to the high-level accounting construct that I'm looking for, and only if I cannot find that do I go deeper. But it's a basic decision. You need to sort of identify what is the most appropriate and most accurate element in the US GAAP taxonomy that represents your accounting concept, and then use fallbacks if that's not available. But that clearly avoids double counting, that approach that I used here.
Right. Okay.
Do you have any more questions?
I think that's it for now. I do want to point out there was a very early question, but it wasn't quite related to our subject today. But it was asked, and it was this question about how do we determine what gap fields are required to be filed for a 10Q. I just wanted to point out if you have other questions, you can send these questions to info@xbrl.us, whether it's questions directly related to this webinar or questions that are on other subjects as well, assuming there's something about XBRL. We love to answer questions. So you can always send us an email at info@xbrl.us. And I would also just say thank you to Alexander for this presentation. Some of the feedback I've been getting besides the questions was really a thank you for this, really enjoying this webinar. I'll point out that we'll have the recording for this webinar available probably in about a day. The slides will become available as well, and Alexander will be releasing a lot of the code behind this, not just some of these snippets, but the code available. So you should look at it in more detail and spend more time going through this, and that will be coming out later. And when that's available, we'll try and follow up and the note indicating that's available. So this has been a really great webinar. I think for a lot of our technical webinars, we got to dive a lot deeper into some of the technical aspects of what you're doing here of processing XBRL data directly from the SEC. That's been really great. And I just want to remind everyone just on some upcoming events. There's the XBRL International Conference coming up in June. It's June 9th through the 11th. I believe the early registration process is now open, and you can get information about that at conference.xbrl.org. And XBRL US will be hosting another XBRL US data forum. It will be in September in Bellevue, Washington. It's on September 16th. And you can find out more about that by going to our website at xbrl.us/dataforum. You can find details about the events from last year's data forum, and we're not open to registration yet on that event, but you can find out more information about that as well. And I'm sorry, I was just checking if there's any more questions that we have. And there is. And one of the questions was, how far back is the XBRL data provided for companies?
2005 is when the voluntary submission process started, and so the first filings were April of 2005.
Okay. And
but it's not complete in the sense not all companies supplied the data at that point in time. The mandatory filing requirement was only what, 2009, 2010.
Right, I think it was 2009, I believe.
Yep.
That's when the filing started. Yeah. And for getting more information about some of the tools or Raptor XML, what's the best way of contacting you, or where to get more information?
All of the information obviously is on the website. You can see some of the links on the final slide. Right now, it's www.altova.com, and then either click on Raptor XML there, the products, or just use the entire URL that's here on the screen right now.
Great. All right. So I believe we're running a little bit over, which is fine. But Alexander, again, thank you very much for this webinar. Again, if there's any follow-up questions or more information that people want to know, you can always contact us at info@xbrl.us. Thank you very much.
Thank you, Phil, for moderating, and thank you, everybody, for coming.